Let's now find the trigonometric ratios of 0 degrees and 90 degrees. Consider a right-angled triangle ABC, right-angled AB. Let us see what happens to the trigonometric ratios of angle A. When angle A equals 0 degrees and angle A equals 90 degrees. Trigonometric ratios of angle A equals 0 degrees. If angle A is made smaller and smaller in the right triangle ABC till it becomes 0, then the length of the side BC decreases, that is, BC becomes 0. As angle A gets smaller and smaller, the point C gets closer to point B. And finally, when angle A becomes 0 degrees, AC becomes almost the same as AB. That is, AC equals AB. When angle A is very close to 0 degrees, BC gets very close to 0, we have sin A equals BC by AC, since sin theta equals opposite side by hypotenuse. Sin A equals 0, here, BC equals 0. Also, when angle A is very close to 0 degrees, AC is nearly the same as AB, and so the value of cos A equals AB by AC, since cos theta equals adjacent side by hypotenuse. This is equal to AB by AB, since AC equals AB. This is equal to 1. Therefore cos A equals 1. When A equals 0 degrees, we define sin 0 degree equals 0 and cos 0 degree equals 1. Now let us find the other trigonometric ratios of angle of 0 degrees. Now we have tan 0 degree equals sin 0 degrees by cos 0 degrees, since sin 0 degree equals 0 and cos 0 degree equals 1. This is equal to 0 by 1 equals 0. Therefore, tan 0 degree equals 0. Cot 0 degree equals 1 by tan 0 degrees. This is equal to 1 by 0, since tan 0 degree equals 0. Therefore cot 0 degree equals not defined. Secant 0 degree equals 1 by cos 0 degrees. This is equal to 1 by 1, since cos 0 degree equals 1. Therefore secant 0 degree equals 1. Cosecant 0 degree equals 1 by sin 0 degrees. This is equal to 1 by 0, since sin 0 degree equals 0. This is equal to not defined. Therefore cosecant 0 degree equals not defined. Now let's find the trigonometric ratios of angle A equals 90 degrees. Let us now see what happens to the trigonometric ratios of angle A, that is, A equals 90 degrees. If angle A gets larger and larger, in the right triangle ABC till it becomes 90 degrees, angle C gets smaller and smaller. Then the length of the side AB decreases, that is, AB equals 0. Finally, when angle A is very close to 90 degrees, angle C becomes very close to 0 degrees. And also we observe that the side AC almost coincides with side BC, that is, AC equals BC. When angle A is 90 degrees, angle C is very close to 0 degrees, AC equals BC, we have sin A equals BC by AC, since sin theta equals opposite side by hypotenuse. This is equal to BC by BC, since AC equals BC. This is equal to 1. Therefore sin A equals 1. Also when angle A is 90 degrees, angle C is very close to 0 degrees, and the side AB is nearly 0. Cos A equals AB by AC, since cos theta equals adjacent side by hypotenuse. This is equal to 0 by AC, since AB equals 0. This is equal to 0. Therefore cos A equals 0. When A equals 90 degrees, we define sin 90 degree equals 1 and cos 90 degree equals 0. Now let us find the other trigonometric ratios of angle of 90 degrees. We have tan 90 degree equals sin 90 degrees by cos 90 degrees. This is equal to 1 by 0, since sin 90 degree equals 1 and cos 90 degree equals 0. Therefore, tan 90 degree equals not defined. Cot 90 degree equals 1 by tan 90 degrees. We have tan 90 degree equals not defined. This is equal to 1 by 0. Therefore, cot 90 degree equals 0. Secant 90 degree equals 1 by cos 90 degrees. This is equal to 1 by 0, since cos 90 degree equals 0. Therefore, Secant 90 degree equals not defined. Cosecant 90 degree equals 1 by sin 90 degrees. This is equal to 1 by 1, since sin 90 degree equals 1. Therefore, cosecant 90 degree equals 1.